Hi, welcome to the tutorial for Lab 7, Computational Mechanics. In this lab, we are going to learn how to do a static structural analysis on any type of beam, a stress, strain, and deformation analysis on any type of beam. And we are going to learn how different types of meshes are going to affect our results for these beams. So to do this, you want to open the workbench again, and you want to drag and drop this static structural module that we have. First option is the engineering data of your material that you're using. If you double click on this, you can see the material properties here. You can see the material itself here. You can add a new material, but we are going to deal with structural still, and we are not going to deal with a different material. So we have to create a column geometry. I'm going to right click on this again, open a design modeler. Again, if you want to use any of the other softwares that are available, you are welcome to do so. You don't have to follow the CAD software that I am signing here. Okay, so the design modeler is open, and we want to create a column. We are not going to use the sketching here anymore, and because we want to learn the rest of the capabilities of this. We can go to concept or create, and we can design primitive material. We are trying to do an analysis on a rectangular column. So essentially we want to create a three-dimensional box. See, it is already made here. As you can see, we can change its geometry. It says, it is asking us the starting point for the coordinate system is at 0, 0, and 0. We are not going to change any of this. We can just let this be. We can have the x component of our column again remain as 1, y comma remain as 1, and the z component we can change to 10. So this is a 10-meter column. As you can see, this is supposed to resemble a wing again, which you are going to use this as that you are going to export the fluent analysis, fluent results to this static structural for your final project and do a complete analysis on a wing of an aircraft. Okay, so we essentially have the fuselage here or here, and the rest of it is exposed to incoming air. We have what we want to have. We just have to click generate to get the body we are looking for. Geometry creation part is the easiest part for these tutorials. So go back. We have the geometry created. Then we have to deal with the mesh and the rest of the setup. For this module, we don't really need to close the mesh module to go to the analysis module and the rest of it. All of this, the model, setup, solution, results are in the same window, as you can see here. Just have to wait for it to pop up. Okay, so geometry is imported, and we have the material as a steel, coordinate system. It was designed by the design model. It was assigned by the design modeler, and then we get to mesh. We did talk about changing the element size in mesh in meshing. Here we want to talk about the options, other options we can deal with in meshing. Let's talk about sizing first. So sizing, let's select one of the faces like this. What we can do here, we can just give an element size for this specific surface. So the rest of them are going to have their own things. Essentially, the mesh size, we can assign a very small mesh size here, and the mesh size becomes bigger and bigger and bigger as it progresses towards the other faces, right? So if you have a part of geometry that you want to focus on, you want to have a very small mesh on there. But for the purpose of this exercise, we don't want to do this. There are other options. There are many other options when it comes to meshing. So you can see inflection points, boundary layer meshes, a lot of different types of mesh. But what you want to use is a method. So you are supposed to run the simulation with 3 different types of mesh. For methods, we have to create this, select this body and hit apply here, and then you can change this method from automatic to tetra mesh, hex dominant, and Cartesian mesh, multi-zone, all of these other the different types of mesh. So let's check each of them. Cartesian mesh, I'm not going to change the cell size. I'm just going to let the solver select the mesh size that it thinks is appropriate. You right click on this and generate the mesh. This is your tetra mesh. This is a little too big for our purpose, so you can come back here and change the method, algorithm, and element order here, or you can go back to the mesh here and change the element size from default to, let's do 0.1 meters, 10 centimeters. So much a smaller mesh. Now you're going to see that this is going to give us better results. We can also change the type of mesh from here by this. We can change this method to hex dominant, for example. You have to choose 3 of these for your exercise and run the simulation for these 3. Hex dominant is going to give us essentially square meshes, quad meshes, if you will. These 2 are going to be enough actually for your analysis. But if you need to, you can. Let's do the layer tetra mesh as well. Let's choose one of the easier ones. Sweep probably. Sweep gave us the same method. It sweeps through all of the geometry and chooses the best version of the mesh for your specific case. Okay, so we have the mesh. Let's move on to the solution module. It's right here, static structural. And what we want to do is we want to assign the boundaries. If we treat this as a wing, either here or the other end is going to be just a fixed support. So you come here in your insert, it gives you different types of supports. The supports that we are dealing with is going to be the type of boundaries we are dealing with is going to be pressure or force, or the different types of supports. We're going to do fixed support here and use this surface. So this is part of the wing that is connected to the fuselage essentially. And for the other ones, we are just going to apply pressure. Let's apply pressure to this face. Let's apply 3 atmospheres of pressure, so 3E5 pascals. And we have the pressure. If you leave the rest of the boundaries, they are going to be treated as just free floating boundaries. There's no pressure applied on them. They can move freely. These are essentially free supports. As you can see, there is no free support here, so if you don't apply anything, it will be treated as free support. Okay, then you come to solution. You apply the pressure to one side. We have designed a fixed support. You come to the solution. You can change the solver, types of solver. You don't really need to know any of this at this point. This is just a basic introduction to the software, and you should be able to run your simulation. You right click here to run the simulation and hit solve, or you can hit solve here. As you can see, the solver is progressing and we are done. But one thing we should have done, I forgot to do, is we have to tell the software what type of results we want to see. We want to see deformation, for example, total deformation. We also want to see von Mises strain and stress. We can either solve this again, or we can just say evaluate our results, which is not going to solve this again. It's just going to give us the results. Deformation. This is where the support was, and this is where it is free. We're going to have the most deformation up here, and the least deformation down here. Let's actually have the, yeah. And you can also do an animation of the deformation. It will show you how it deforms. Should be, yes, in this direction. This is where we are applying the pressure. You can see the deformation. We have the support and everything. We can also see the strain. We have the maximum strain here, and the strain becomes smaller and smaller because these are our free floating bodies, so we don't really see any strain. The same is true for stress. Just the value here changes, but the stress, the location of maximum stress is not going to change. So you have to do this for different number of meshes and for different number of pressures, and just submit your results. Of course, you won't be able to submit these animations as a part of your results, but you want to do the maximum strain and maximum deformation. You want to submit these as your results, the screenshots of these. Yeah, and that's it. Please let me know if you have a question. Let me or my TAs know if you have a question about this lab.